Students, good morning.
Good morning, ma'am.
So a quick revision of the values I just want you to just tell me the values of proton and carbon, NMR, delta values. So quickly, okay. So first proton NMR, when you have protons which are attached to alkane protons, values.
I'm 0.5 to 2.
0.5 to 1.9, 1.5. Okay, very good. What about the protons attached to alkene protons? Alkene protons.
2 to 3.
Alkenes.
2
4
to
to
6.
6.
Very good. Okay. Alkyne protons.
3 to 4.
2 to 3.
Very good. Okay. So a proton, CH3 protons attached to alkene, not alkene proton. CH3 attached to alkene. That hydrogens.
2 to 3.
Very good. CH3 or CH2 attached to benzene ring.
I'm a 6.5 to 8,
6
ma'am.
to
No.
7.
I'm not asking benzene protons. CH3 protons attached to benzene rings, not benzene protons, not aromatic protons. CH3 attached to benzene, that CH3 hydrogens will be in what range? Or hydrogens attached CH2 hydrogens or CH3 hydrogens, the hydrogens attached to the benzene ring are different from the hydrogens which are adjacent to the benzene ring, that is adjacent carbon. So benzene, so for example, benzyl, if I say benzyl hydrogens, so the CH2 hydrogens, so they all will be around 2 to 3. So CH3 attached to C double bond O, 2 to 3. The CH3 attached to alkene, again 2 to 3. Alkyne protons, again 2 to 3. Okay, so remember these four categories will be having values around 2 to 3. Okay, now aromatic hydrogens.
7 to 8.
Aromatic
6 to 7.
6 to 8. Okay, so if it is shielded, it will be near 6. If it is de-shielded, it will be near 8. Okay, 6 to 8. So the value of aromatic protons will depend upon whether it's shielding zone or de-shielding zone, depending upon the substituent attached. If you have electron withdrawing group, the ortho protons will be de-shielded. If it is ortho and para will be de-shielded. If you have electron donating group, ortho and para will be shielded. So that is the concept that we have discussed in detail. Okay. So, okay, so you'll be having aromatic 6 to 8. What about aldehyde protons? Aldehyde protons.
I'm
9
9 to 10.
to
So
9
9 and
to
above. Okay. What about carboxylic acid protons?
10 to 12.
10 to
10
12.
to 12.
Okay, okay. Now, what are the protons which can undergo exchange with the solvent or with the medium or with themselves? Exchangeable protons. What are the exchangeable protons?
OH proton.
OH
OH,
proton.
Aldehyde proton.
NH2
Acid
proton.
proton.
OH protons, any one, OH protons, carboxylic acid protons, and
NH2 proton.
Amine
NH2
proton.
or NH, amine protons, primary amine or secondary amine. Okay. Will tertiary amine protons exchangeable? Tertiary amine.
No, ma'am.
Tertiary amine does not have an hydrogen. Okay. So there will be no exchangeable hydrogens attached to the tertiary amine. Okay. Tertiary nitrogen will not have any hydrogen. So they will be not exchangeable. So only primary and secondary will be having exchangeable hydrogens. Okay. To keep this in mind. Okay. So very clear you are people are. So now last class we started with this type of problems where you have to solve the problems based on the NMR values alone. Okay. No splitting data will be there. So we have categorized the problems. So first set of problems which we saw was basic problems on introduction part. The second set of problems were based on the number of signals. So you have to divide the molecule, cut the molecule. You have to check whether they are homotopic, enantiotopic, or diastereotopic. You know that if homotopic and enantiotopic, they'll be chemically equivalent. If they are diastereotopic, they'll be chemically non-equivalent. Okay, so chemically equivalent protons will give you same signal. Chemically non-equivalent protons will give you different signals. That was the second set of problems. The third set of problems which we were looking now is the NMR problems based on just NMR data, the delta values with chemical shift. So you people know very clearly the delta values. Now of protons attached to a heteroatom, what is the range? What is the range? Protons attached to heteroatom. Yeah, come on, guys.
Ma'am, 4 to 5, ma'am.
Yeah, so there will be the range of 4, okay? And depending upon the electronegativity of the heteroatom, you'll be having a range. So, for example, if CH attached to fluorine will be having the most de-shielding because fluorine is the most electronegative element. So, depending upon what kind of atom attached, you can have inductive effect. Based on inductive effect, you'll be having shielding and de-shielding, okay? So, heteroatom, generally the ranges you can keep as 4. So it can be less than 4 or more than 4, but it will be in that particular range depending upon the electronegativity of the atom attached. Okay. Now coming to carbon, alkane, primary, secondary, tertiary, whatever. What is the alkane carbon range? Range of alkane carbon.
30, ma'am.
Very good. So it can vary from 0 to 30. So 10, 20, 30, it will be in that range. Okay. So carbon attached to heteroatom around
60, ma'am.
very good. Then you have alkyne carbon. Alkyne carbon.
80,
Very good. Alkene carbon.
110, ma'am.
Very good. Aromatic carbon.
130,
Very good. Then you have C double bond O, acid, ester, amide, acid chloride. That's C double bond O carbon, carbonyl carbon.
170, ma'am.
170. So up 170 is the range. It can have. We are talking about range. Okay. So the values will be higher or lower depending upon what kind of functionality you have. Okay. So acid, ester, aldehyde, amide, acid chloride, all will fall in this range: 187, 190, and around 170. Okay. Now, if you have greater than 200, what does it mean?
Ketone group, ma'am.
Very good. That's also if people are thorough with the values. Now we can straight away look into the problems. Okay. What is the answer for this particular question? The first thing is you should draw the structure for methyl 4-oxopentanoate. So it is an ester with keto functionality in it. Okay. So first you need to know, write the structure. Okay. This is a structure. Okay. Methyl. So first ester will be named with the methyl and 4-oxopentanoate. Okay. So this is the structure of this particular compound. Now tell me what is the right answer. Straight away, you can rule out two options. Which are there? Two options. Straight away. Takkana rule out panila. Enna options?
Ma'am, A and B, ma'am.
A and B. Why? Based on what?
Ma'am, C4 carbon is ketone, ma'am.
Very
And it
good.
will
So
be around more than 200.
carbon, yeah. Keto carbon will come about 200, okay? So here C4, they've given 172. Here also is 172. So I can have option A is wrong, option B is wrong. Another option I can straight away rule out. What is that? Based on a basic, simple information. Rombola yosike van the problem. Anyone could you tell me which other option I can rule out? Or which is the correct answer? So whenever you give a right answer, you should check that all the carbon are placed in the exact values. Guys, you are there or you people have left? Are you all there?
Yes, ma'am. We are here, ma'am.
Yeah, then tell me what is the right answer?
Ma'am, D
What
is the right
about
answer.
this carbon? What about this carbon? What will be the value of this carbon? O methyl carbon. The carbon attached to oxygen. What will be the value of this particular carbon?
Ma'am, 60, ma'am, around 60.
Around 60. So which option is wrong?
C is wrong, ma'am.
She is wrong. That's all because it is coming 30. 32. So a carbon attached to an heteroatom. The heteroatom can be either oxygen or nitrogen or halogen. So an heteroatom attached to the carbon, this carbon will be having a range of 60, above and below 60, okay, not 32. So 51 is agreeable, okay. So the answer is option D, okay. So the O methyl carbon around 51, the C1 carbon is an ester carbon will be around 172, and C4 carbon 208, and the C5 carbon, the carbon CH attached to C double bond or not on a heteroatom directly, okay, so it will be around 32. So we can see that the option D is agreeing with all the values of carbon, so answer is option D, okay. So same way we have proceeded here also. So you can also look into how you are just trying to target the problem. எப்படி நீங்க approach பண்ணீங்க, that is very important, okay. So what we find is option D is the right answer. Okay. Now coming to this, 4-hydroxybenzoic acid exhibits signals at the following values. So again, they've been broadband decouple. So when I do broadband decouple, all the splitting patterns will be lost. I'll be having only singlets for all the different carbons. Now, could you tell me what is the right answer here? So you need to know the structure. So if this is your 4-hydroxybenzoic acid. Will you name this? So carbon 1, 2, 3, 4, 5, 6. This is COH carbon. Okay. Now tell me. Yeah, guys, tell me which is the right answer. Are you all there, or you all have left the meeting? So don't be dumb. So just give some prediction so that we can proceed further.
Option B, ma'am.
Option D or B?
B, ma'am. A, B.
B. Why B? Why B? Could you just justify your answer?
Yes, ma'am, because third and fifth position is near to OH group, which is an electron donating group, ma'am.
Very good. So since OH is plus R group, the third and fifth will be shielded. You'll be having shielding, okay? So they will be shielded. You'll be having negative charge. Okay, I agree. So this is right. So 3 and 5 should be having 116. But all the 4 are 116. So I cannot make a differentiation based on that. In all the cases, so 3 and 5 is, sorry, this is 2 and 6. So this will be wrong. Okay, this is wrong. Very good. Okay. I didn't check that. Okay. So 3, 5 and 3, carbon 3 and 5 will be shielded because of the electron donating group. Okay, then what else? What
2
else?
and 6 are near to electron withdrawing group, ma'am.
Okay, so you have this C double bond or carboxyl is minus R group. So they will be de-shielded. Okay, so there will be 2 and 6 will be de-shielded. So you are saying its value could be 133. Okay, then what else?
And for carboxyl group, the value will be high, ma'am, 171.
Yeah, so they have given C1, 171. They have this person C4. They have given 171. Why? Because they are just giving the range is 171 because it's attached to oxygen. But it cannot be so very de-shielded because we have carboxylic acid, and already we have told that carboxylic acid, aldehyde, ester, all that will come in the range of 170. Okay, so C4 cannot be 171. Okay, so these two are straight away ruled out. So I can have 171 carboxylic acid. That also I agree. Okay, then carbon 4 attached to oxygen electron withdrawing. This is aromatic carbon. Aromatic carbon already will be in the range of 130. And since you have electron withdrawing oxygen, it is highly de-shielded. Okay. So not only that, you can just visualize that carboxylic acid. Carboxylic acid is a minus R group that withdraws the electrons. So it withdraws the electrons, making the ortho and para de-shielded. So it is pulling the electrons away from ortho and para. So this carbon will be carrying a positive charge because of that. And not only that, you'll be also having the minus I effect of OH. So that makes this carbon highly de-shielded. Okay. So that is why you have a value of 162. Okay. So now how will I approach the problem is, I will see that the carboxylic acid carbon, this carbon will be having a value of around 170. So I will straight away rule out option A and B. I'll straight away rule out option A and B. Okay, now compare the A and B option. A and B was 171. This is same. This is same. And what else is same? 122, 122 is same. What they have made the difference is, they have made the difference between C3, 5 and 3, 2 and 6. So it becomes very easy to solve the problem. To get the point, 1 second. So how should we approach the problem? See, so since you have a carboxylic acid carbon will be coming around 170 range. So you can rule out this carboxylic as 162. That's wrong. Same 61 is wrong. So I ruled out option A and B. Very simple. It goes very easy. Okay. So now in option B and D, this is same, and also this is same. The only difference lies in this and this. So that is the only confusion they have brought in the problem. There is no confusion. So now you know that since this OH is plus R group and C double bond O is a minus R group, these two protons will be shielded and these two hydrogens will be de-shielded. Just that is the way we have to approach. Okay, therefore 2 and 6. So you will be having 3, 2 and 6 will be de-shielded. So we have numbered because carboxylic acid giving higher preference for that substitution. So 1, 2, 3, 4, 5, 6. So 2 and 6 should be de-shielded because it is attached to electron withdrawing group. Therefore, they'll be having higher value, 133. And 3 and 5 will be shielded because they are attached to electron donating group. So that is how I should approach the problem. Okay. So don't try to look in, okay, idhukku enna value irukonu, idhukku enna value appadi pogama idhukku indha value dhaan irukonu idu irukkodadhu poiningna, you will have straight away that will land you to the problem answer. Okay, so that is how you should approach. Okay, now next problem. Compounds A and B exhibits two signals each in their proton NMR spectrum. The expected chemical shift are at delta values. So here we have to check on the proton NMR data. Okay, not carbon, proton NMR data. Quickly give me the answer. Yeah, anyone?
Option A, ma'am.
Option A is right answer, you are saying, is it not? How did you come up? How did you just zero down to option A?
Because in option B, electron withdrawing group is directly connected, ma'am.
To benzene ring, you're talking about benzene ring?
Yes, ma'am, to benzene ring.
Yes, very good. So these are minus R group. So since they are minus R group, the benzene proton should be de-shielded. Very good. And this O is, so benzene directly attached atom as a lone pair of electron, they will be acting as electron donating group. So here you have plus R group. So these hydrogens will be shielded. I agree. Very good. So A will be shielded. A will be having aromatic region shielded. B will be de-shielded. Very good. Okay. So I have the second option. C also has same kind of values. Then what you will do? So based on this, I can rule out option B and D. Okay. Now, how will you just get the answer from option A and C? So what you said is absolutely right, ma. But how will you just now zero down? Because option A and C are very similar. Based
Ma'am,
on
in
the
option B, methyl group is attached to the hetero atom, ma'am.
very good. In compound B, the methyl is attached to an heteroatom. So it will be having a value around 3 and something, 3.5, 3.4, 3.6. And since you just remember that if you have an oxygen attached to, if an protons attached to methyl, they will be around 3.6. But when you have a something of this kind, O, further you have an OCH3. Now what happens is that these lone pair of electrons are in resonance, so they'll be carrying a plus charge. Therefore, this will become highly de-shielded. They'll be coming around 4. Okay, so CH3 attached to oxygen will be around 3.6 or 3.5, whereas CH3 attached to O followed by C double bond O will be around 4. So they're given 3.9. So B will be 3.9. Whereas this methyl attached to a C double bond O, we already seen. What are the methyls which will give you 2 to 3? எதெல்லாம் கொடுக்கும் சொல்ல முடியுமா டக்கு டக்குன்னு? எதெல்லாம் hydrogens 2 to 3 குள்ள வரும்?
alkane and alkyne.
Alkyne, okay, so the protons attached to alkyne carbon, then double bond la attached protons illa double bond பக்கத்து carbon la இருக்கிற hydrogens, alkene hydrogens will be around 4 to 6. So alkene பக்கத்து carbon la இருக்கிற hydrogens. Okay, then benzene ring பக்கத்து carbon la இருக்கிற hydrogens. Okay, then you can have a C double bond O, the neighboring hydrogens. So these are the 4 category of hydrogens which will have a range of 2 to 3. Okay, just remember that. So now you have a methyl attached to C double bond O. This methyl will be around 2 to 3, not around 3.9. Okay, so this is the right answer. So you should find some ways and means by which you can rule out certain options and straight away land to the right answer. Okay. So what you did is absolutely right, ma. Answer A is, option A is the right answer. Okay. So how you approach? So here A is the right answer. Okay. So how did I approach the problem? I just, as she pointed out rightly, you have the methyl attached to oxygen. Okay. So it will be around 3.9. Okay. So if B protons, it is around 3.9. 3.9. So this is wrong. This is wrong. Wrong and wrong. Okay. So I can rule out that. Then you have oxygen, which are plus R group, and this C double, which is minus R group. So based on that, I can say that the A cannot be A. Since you have plus R, these should be shielded. So 7.7 is wrong, 6.9 is wrong. So I ran up. See, it will just take few seconds, just moments you need to know how you're going to approach the problem. So answer A is the right answer. Okay. Guys, quickly tell me this. Very easy problem. என்னமா?
Previous questionல singletா அது signals ஆ மேம் அது?
இது வெறும் 2 singlets கொடுத்திருக்காங்க. நம்ம இன்னும் கப்ளிங் போகவே இல்ல. But anyway I can explain that. So 2 singlets சொல்லிருக்காங்கன்னா என்ன சொல்ல வராங்கன்னா can you tell me why they say 2 singlets? இந்த molecule ரெண்டே ரெண்டு singlet கொடுக்கும், இந்த molecule ரெண்டே ரெண்டு singlet தான் கொடுக்கும். When you say there are only singlet, that shows that there is no splitting. There is no splitting. Splitting ille nadakkalena enna arthomna, there are no neighboring protons. Neighborல protons இருந்தாதான் நம்ம splitting நடக்கும். So there is no splitting, there is no neighboring protons. Adjacent protons இல்லைன்னு அர்த்தம். So அதான் இங்க clue. So இங்க ரெண்டு singlets சொல்றாங்கன்னா, can you tell me now? Tell me ma. Since you have asked this question, don't think that okay நம்ம கேள்வி கேட்ட தப்பா question நினைக்க கூடாது. You try to answer, I'll help you out. Why I say this molecule will also give you 2 singlets, this molecule will also give you 2 singlets. Tell me why?
மெத்தில் குரூப் இருக்குல்ல மேம், அது ஒரு சிங்லெட் மேம்.
Okay, very good.
அந்த பென்சீன்லனா ரெண்டு ஹைட்ரஜன் இருக்குல்ல மேம்.
Yeah. Let me come.
Equivalent protons
இன்னும் என்ன பண்ணிட்டோம், நம்ம ஏற்கனவே படிச்சிருக்கோம் number of signals. So the benzene ring இப்படியும் கட் பண்ணலாம், இப்படியும் கட் பண்ணலாம். So இந்த ஹைட்ரஜன் பாரு, இந்த ஹைட்ரஜன் பாருங்க, இந்த ஹைட்ரஜன் பாருங்க. நீ கட் பண்றது விடு. Just look at this hydrogen. This hydrogen neighboring carbon has an OC double bond O. This hydrogen neighboring carbon also has OC double bond O. This hydrogen neighboring carbon also has OC double bond O. This H also has OC double bond. So all the 4 hydrogens are equivalent. Thambi purinchapa.
ஓகே இது 2 சிக்னல்ஸ் ஓகே மேம். அந்த சிங்லெட் 2 சிங்லெட் சொன்னீங்கல்ல அந்த ஹைட்ரஜன் வந்து அப்படியே தான் இருக்கு.
ஏன்னா நான் இன்னும் ஸ்பிளிட்டிங் போல பட் நீ கேட்கறதுக்காக சொல்றேன். ஒரே டைப் ஆஃப் புரோட்டான்ஸ் நல்லா ஞாபகிச்சுக்கோங்க, ஒரு மனசுல பதிச்சுக்கோங்க. கெமிக்கலி ஈக்குவலன்ட் புரோட்டான்ஸ் will not split each other. நான் இன்னும் டீடைல் இந்த கிளாஸ்ல அதான் நடத்த போறேன். அடுத்து ஒரே வீட்ல இருக்க புரோட்டான்ஸ், ஒரே வீடுனா நம்ம என்ன சொல்ல வரோம்னா கெமிக்கலி ஈக்குவலன்ட். கெமிக்கலி ஈக்குவலன்ட் புரோட்டான்ஸ் ஒரே வீடு, நேபரிங் புரோட்டான்ஸ்னா வேற வீடு. நேபர்ஸ் நம்ம வீட்ல இருக்கோம், நம்ம வீடு பக்கத்து வீடு நேபர் சொல்றோம் இல்லையா, அதே மாதிரிதான். சோ நம்ம வீடு பக்கத்து வீடு நேபர். சோ இங்க என்ன சொல்றாங்க, நேபரே இல்ல, எல்லாமே ஒரே வீட்ல இருக்காங்க. சோ ஒரே வீட்ல இருக்க புரோட்டான்ஸ் தனக்குள்ள ஸ்பிளிட் பண்ணாது. அப்படின்னா என்ன அர்த்தம், ஒரே வீட்ல இருக்க புரோட்டான்ஸ் தான் they are chemically equivalent, they give you same signal. so chemically equivalent protons தனக்குள்ள split ஆகாது. தம்பி புரிஞ்சா?
ஓகே மேம் ஓகே மேம்.
சரியா? வெரி சிம்பிள் திங். chemically equivalent protons will not split each other. okay, so ஒரே வீட்ல இருக்க neighboring protons பக்கத்து வீட்ல இருக்க protons மட்டும் தான் ஸ்பிளிட் ஆகும், தனக்குள்ள ஸ்பிளிட் ஆகாது. சோ இந்த 4 ஹைட்ரஜனும் chemically equivalent. so chemically equivalent split. so இந்த ஹைட்ரஜன் இத ஸ்பிளிட் பண்ணாது, so இந்த ஹைட்ரஜன் ஸ்பிளிட் பண்ணாது because they are same. நம்மள ஒரே குடும்பம், ஒரே ஃபேமிலி. so நம்மளுக்குள்ள எந்த ஸ்பிளிட்டிங் இல்ல, எந்த சண்டை இல்ல, எதுவுமே இல்ல, no splitting. so they all four will give you one signal, and these 2 methyl will give you one signal because they are chemically equivalent. Similarly, these 2 methyls will give you one signal, and all the 4 protons will give you one signal. Is that okay, ma, for you? Have you understood? Yes?
எஸ் மேம் எஸ் மேம்.
Okay, okay. நம்ம இன்னைக்கு எதான் அடுத்த டாபிக் அதான்ப்பா. spin splitting, spin coupling அடுத்த டாபிக். சரியா? You'll be having geminal coupling, vicinal coupling, all that I'm going to teach you today. Okay? Okay, now very interesting problem. Match the following. ஸ்ட்ரெயிட் அவே ஒரு ஆப்ஷன் போகணும்னா ரெண்டு தூக்கிடலாம்ப்பா. ஒரே ஒரு நமக்கு தெரிஞ்ச ரொம்ப 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 தெரிஞ்ச ஒரு வேல்யூ, அதை வச்சு நம்ம 2 ஆப்ஷன் தூக்கி விட்டுறலாம்.
பிடி வந்து கேன்சல் பண்ணிடலாம்.
என்னமா
மேம் சி கேன்சல் பண்ணிரலாம்.
பி அண்ட் சியா?
பி அண்ட் டி மேம்.
பி அண்ட் டி எதை வச்சுப்பா?
இந்த அசிட்டோன் வந்து 250.
Very good, awesome. So acetone will be having 205. That is C should be having 4. So நீ காலி ஆயிட்டு, நீ காலி ஆயிட்டு. Okay, now I have A and C. So C should be 4.
மேம் ஆசிட் சொல்லலாம் மேம்.
ஆசிட் என்ன சொல்றீங்க? ஆசிட்.
3.
Very good, முடிஞ்சு.
மேம் A க்கு 3 வரும். எஸ் மேம்.
Very good. So acid carboxylic acid will be having, yeah, C double bond O of carboxylic acid will be around 175. So C will be out. Very good. Super pa, முடிஞ்சு, problem முடிஞ்சு. So acetic acid 175. Acetonitrile is CH3 C triple bond end. B எங்க வரும்? Acetonitrile, the carbon we're talking about the nitrile, alkyne carbon range என்ன சொல்லிருக்கோம்?
70 to 90. 80 around.
Almost nearly 80 நம்ம சொன்னோம். Triple bond 80, but heteroatomனால it will be having 190. Okay, so 115. Then you have carbon tetrachloride, carbon attached to heteroatom என்ன range சொன்னோம்? Around 60. Okay, so that will be having, very good, very simple. Rombo within seconds you people have found the answer. So right answer is option A. Very good. So அதே நானும் அதே சேம் அப்ரோச். நீ எப்படி சால்வ் பண்றீங்களோ அதே மாதிரி நானும் சால்வ் பண்ணி பாத்தீங்க. சோ நான் எப்படி என்னோட அப்ரோச் இப்படிதான், நான் இப்படிதான் அப்ரோச் பண்ணேன். சோ அசிட்டோன் வச்சு 2 ஆப்ஷன் ரூல் அவுட் பண்ணேன். தென் அசிட்டோனைட்ரைல் வச்சு ரூல் அவுட் பண்ணேன். ஓகே, you people have gone with acid, no problem. Okay, so what we have found is right. So the answer is option A. Very good, very good. Next problem, very interesting. I like this problem very much. Then a concept is it? What is this concept?
Ma'am, anisotropic effect.
Yeah, anisotropic effect. Before that, anisotropic போறதுக்கு முன்னாடி என்ன கான்செப்ட்?
Homo aromaticity.
Very good, homo aromaticity. Okay, so when you take cyclooctatetraene, what do you know about the aromaticity of say cot?
Non-aromatic, ma'am.
So cot will always exist in tub shape. Okay, it will exist in Subshape. Aromaticity is again a very interesting topic. I think you have learned from some students of mine that you have studied aromaticity in detail, so you might be able to explore the ideas. Okay, or just explore the ideas of aromaticity into NMR. We are going to bring it. Okay, cod is generally non-aromatic because it is non-planar. So aromaticity is மூணு முக்கியமான condition தெரியும். So non-planar and non-aromatic iron. Now what we have done here is that you are going to make when you react with H plus ion, suppose I have this, so you'll be having a plus here, you'll be having a minus here. So what will happen? So the H plus will react with the carbon minus. So what will happen? So you'll be having hydrogen, two hydrogens, and this carbon will carry a plus charge. Okay, something like this. Now what happens if I have something like this? What is this compound known as? Cycloheptatrienyl cation. What is that?
Tropylium.
Ma'am, tropylium ion.
Tropylium ion is aromatic. You might have studied this. Is it not? Or if
Yes,
I take
ma'am.
cycloheptatrienyl cation, so you have three ions you might have studied. Cyclopropenyl cation, cyclopentadienyl anion, and cycloheptatrienyl cation. So it's aromatic தெரியும். ஆனா இங்க என்ன ஆயிடுச்சு? நம்மளோட prerequisite-ல அடி ஆயிடுது. So we know that the three prerequisites says that it should be cyclic. It is cyclic, I agree. Then you should have conjugation. So conjugation அடி ஆயிடுச்சு. Why? Because you have double bond, single bond, double bond. You have a charge here, but this carbon is sp3 hybridized. So we have one of the condition, all the carbon should have an unhybridized p orbital. So sp2 irkalam, but sp3 irundhuchna unhybridized p orbital irukadu. So conjugation cut ஆயிரும். So அப்படி பார்த்தா இந்த molecule will become non-aromatic because you have an unhybridized p orbital. So molecule என்ன பண்ணுது? Molecule wants to become aromatic because you know that a molecule, if it becomes aromatic, it becomes highly stable. So molecule wants somehow எப்படியாச்சும் நான் ஸ்டேபிள் ஆகணும், எப்படியாச்சும் நான் சிஎஸ்ஆர் கேட் கிளாஸ் அட்டெண்ட் பண்ணி நான் சிஎஸ்ஆர் கிளியர் பண்ணி நான் பெரிய ஆள் ஆகணும். அதேதான் நீங்களே எப்படி ஆர்வமா இருக்கீங்களோ அதே மாதிரி என்ன ஆகுது? மாலிகுல் என்ன ஆகுது? மாலிகுலும் ஆர்வமா இருக்கு. It also wants to become aromatic because if it becomes aromatic, it becomes highly stable. So that is what it does. What it does, it lifts this particular carbon away from the plane. So in the carbon, plane mele thookirum. That is what it has done. So this carbon comes above the plane. Now you can see you have carbon 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon. 7 carbon with a plus charge. That becomes cycloheptatrienyl type of system. And this 1 carbon is above the plane. So since this 1 carbon has gone above the plane, now you have a bottom structure which follows all the rules. It is conjugated, so it is cyclic, it is having a conjugation, all the carbons are having an unhybridized p orbital. Okay, so in the one carbon mele thookirum. This is known as homoaromaticity. Homoaromaticity. You might have studied this, is it not? Okay. Now, since now it has become an aromatic compound, it will generate a ring current. Ring current போயிட்டு இருக்கும். So ring current போனா punctually anisotropics will be having an secondary magnetic field, and secondary magnetic field will be aligning near the outer protons, and near the inner protons it will be opposing. So enna ஆயிடுது? HA is outerல வந்துருது, outer zone வந்துருது, HB inner zone வந்துருது. So இப்ப சொல்ல முடியுமா யார் ஷீல்டடா இருப்பா? HA ஷீல்டடா, HB ஷீல்டடா aromatic systemல?
HB ma'am.
HB. So நம்ம என்ன பார்த்திருக்கோம்? நம்ம என்ன பார்த்திருக்கோம்? aromatic systemல outer hydrogens are de-shielded, inner hydrogens are shielded. அதே anti-aromatic compound என்ன ஆகும்னா அந்த ring current தலைகீழ சுத்தும், opposite சுத்தும். Therefore the secondary magnetic field opposite சுத்தும். So you'll be having, this will be the rotation of the ring current. So you'll be having a different rotation of the magnetic field. Okay, so you'll be having something like this. So இது இங்க எப்படி போகும், இங்க align ஆகும், இது opposite பண்ணும். outerல என்ன ஆகும்? outer will get shielded, inner will get de-shielded. So since it is an aromatic system, outer will be de-shielded, inner will be shielded. So appdi pathona, these H1 and 7, H2, 6, they are aromatic protons. Aromatic protons range இப்படியே தான் இருக்கும். Okay, so they will be in the aromatic range. இதை நம்ம பார்க்க தேவையில்லை. Now you can say that HA is de-shielded, so it will be having a value of 5.1. H will be shielded, that will be having a value of minus 0.3. Okay, so look into the option HA, that is P should be 2. P2 ரெண்டு ஆப்ஷன்ல இருக்கு. P2 ரெண்டு ஆப்ஷன்ல இருக்கு. P2 Q1. So P2 இங்கேயும் P2 இருக்கு, இங்கேயும் P2 இருக்கு. Q1 இந்த ஒரு ஆப்ஷன்ல மட்டும் தான் இருக்கு. So answer is option 1. Or do you all agree with what I'm talking? Do you all agree? Yes?
Yes, ma'am.
Yes. So that is how we found. So HA is shielded. It is having 5.1. So you'll be having option ruled out. So option 2 and 3 will be ruled out. Then HB will be shielded. Therefore, option 3 will be ruled out. Sorry. Option so 4 will be ruled out. And then you have option 1 as the right answer. Okay. So P vachi நம்ம ரெண்டு option rule out பண்றோம். Q vachi third option rule out பண்றோம். Fourth option rule out பண்றோம். And based on that, we find the right answer. Okay. Next problem. Very simple. The circled hydrogens or the values கண்டுபிடிக்கணும். Circle hydrogen values கண்டுபிடிக்கணும்னா first அந்த system aromatic anti aromatic நீங்க கண்டுபிடிக்கணும். அதுக்கு உங்களுக்கு basic Huckel's rule தெரியணும். What are the Huckel's number? Huckel number எதெல்லாம் Huckel number? Aromatic. Huckel's aromatic number எதெல்லாம்?
2, 6, 10, 14.
Very good. 2, 6, 10, 14, 18. Okay. What is the Huckel's anti-aromatic number?
4, 8, 12.
0, 4, 8, 12, 16. Very good. Okay. Now tell me based on this. Now tell me this compound. Compound number 1. How many pi electrons it is having? So for alkyne, count only 1 because alkyne like this 1 will be because you'll be having the alkyne will be having something like this. You might have studied. You'll be having something like this. So only one particular p orbital will be involved in conjugation. The other one will be perpendicular to it. So இந்த ஒரு pi bond எடுத்தா போதும். So ஒரு pi bond, ரெண்டு pi bond, 3, 4, 5, 6. So how many pi bonds I have here? How many pi bonds?
6, ma'am.
6 pi bonds. So how many pi electrons?
12, ma'am.
So 12 pi electrons. So 12 pi electrons, it's aromatic or anti-aromatic?
Anti-aromatic.
Anti-aromatic. So this is anti-aromatic. So anti-aromatic na inner proton shielded or de-shielded?
De-shielded.
De-shielded. Mudunchu. So they should be de-shielded. Okay. So de-shielded na, they cannot be in aromatic region. So de-shielded means it will be having around 16.4. Okay. Now coming to this compound 3. Compound 3, how many pi electrons? 1, 2, 3, 4, 5, 6, 7. So you have 7 pi bonds. Therefore, how many pi electrons?
14,
pi?
ma'am.
14 pi electrons. 14 pi electrons. 14 is what? Aromatic or
Aromatic.
aromatic? So it is an
Aromatic.
aromatic. Aromatically, inner protons என்ன ஆகும்?
Shielded.
Very
Shielded.
good.
நம்ம இன்னும் shielded இருக்கும்.
Shielded. Shielded value என்ன ஆகணும்?
Decrease ஆகணும். நம்ம கம்மியா இருக்கணும்.
கம்மியா இருக்கணும். So 3 should be C. 1 should be A. 3C நால 3 and 4 gali. 1 should be A நால 2 gali. So what is the answer?
Ma'am, 1 should be B then, ma'am.
Sorry. 1 second. 1 second, guys. 1 second. So 3 should be C. Therefore, I can rule out option 4 and 3 and 4. And 1 should be B. Based 1 should be B. Therefore, I can rule out option 1. So answer is option 2. Okay. And 2 is nothing but it's like an alkene proton, alkene hydrogens. Alkene hydrogen will be having range of 4 to 6. Since you have a C double bond to attach, yet you have a de-shielding. Therefore, you'll be having the value around 6.72. So 2 should be should be A. So, Ninga aromatic anti-aromatic approach pani, you can solve this problem. Okay. So the answer is option 2. Do you all agree with this, guys? All of you, do you agree
Yes,
with
ma'am.
this?
Yes, ma'am.
Yes. Okay. So anti-aromatic. This is, so I can rule out 1 and 4. Then aromatic. So way you approach. Okay. Now tell me this. Very simple problem. Guys, ரொம்ப சிம்பிளான ப்ராப்ளம். ஓகே, ஒண்ணுமே இல்ல. பென்சீன் வேல்யூ என்ன இருக்கும்? பென்சீன் வெறும்
Ma'am,
பென்சீன்
5 to 6 to 7
Option
இருக்கும்.
A, ma'am.
பென்சீன் வேல்யூ 6 to 8 இருக்குமா? சோ ஒரு பென்சீனோட வேல்யூ 7 கிட்ட. ஓகே, சோ நியூட்ரல் 7 கிட்ட. சோ என்ன பண்ணலாம்? ஏதோ ஆப்ஷன் ரூல். சோ 2 should be 7.2. D C gali, D gali. Then in the arom, this is aromatic, this is also aromatic. But உள்ள என்ன சார்ஜ் இருக்கு? உள்ள என்ன சார்ஜ் ஓடிட்டு இருக்கு?
Negative and positive. Yes,
பாசிட்டிவ் சார்ஜ் என்ன அர்த்தம்?
D shielded, ma'am.
D shielded. இங்க நெகட்டிவ் சார்ஜ் என்ன அர்த்தம்?
Shielded, ma'am.
So இந்த கார்பன் எல்லா protons, it is surrounded by plus charge. Here all the protons surrounded by negative charge. So shielding now you'll be having low delta. D shielded will be having high delta. அவ்வளவுதான். So 3 should be D shielded. So what is the answer? 1 should be shielded. What is the answer?
A.
Option A. Very option A. That's all. Very simple. So 6 to 8 and shielding 3 should be D shielded. 9.2 A 1 should be shielded. 5.4. So answer is option 1. Okay. Okay. This you know 18 aniline already we have discussed in detail. 18 aniline is aromatic. Do you agree? 18 is an Huckel's number.
Yes,
4n plus 2 is equal to 18. 4n is equal to 16. N is equal to 4. So it is aromatic. Yes. It is having cyclic. All the carbon has anhydrous p orbital. It is planar. It is aromatic. Okay. The inner proton resonance is 9.28 and it's in the NMR spectrum. Do you agree with this?
No, ma'am.
So in,
No, ma'am.
in aniline, what happens? You have 12 outer protons and 6 inner protons. So this is an aromatic system. Therefore, what will happen? The secondary magnetic field will be such a way that near the inner protons, it is opposing. So if this is the magnetic field, applied magnetic field, so near the inner protons, that is opposing. Since it is opposing, you have shielded. Here near the outer protons, it is aligning. Therefore it is de-shielded. So aromatic system, inner protons shielded, outer protons de-shielded. So in nariya problems ketingna, you will be saying 6 hydrogens, aniline 6 hydrogens will be shielded. They'll be having a value of minus 3.0 and 12 outer protons. So they are inner protons, outer protons. 12 outer protons will be de-shielded. They'll be having a value of 9.0. Just keep that in mind.
Doubt, ma'am.
Yeah, tell me, ma'am.
Ma'am, how will you decide the direction of the electron flow, ma'am?
Which one? So see, these all are experimental connections which we are flowing. See, நம்மளுக்கு actually பாத்தீங்கன்னா இந்த மாதிரி aromatic ringல அந்த ring current பண்றதுக்கு physical techniques இருக்கு. Physical method. So normally பாத்தீங்கன்னா you have a scientific page. Aromaticity and ring current ஒரு scientific page இருக்கு. அதுல பாத்தீங்கன்னா they have looked into the ஏதோ data. எனக்கு அந்த exact அந்த technique ஓட name ஞாபகம் வர மாட்டேங்குது. Maybe I'll just tell you in the next class. There is a technique whereby what they have done is that they have looked into the that is electrons around the hydrogens in an aromatic system. So அந்த மாதிரி பாக்குறப்ப அந்த என்ன சொல்லுவாங்க zone of electrons check பண்றாங்க. அந்த zone of electrons check பண்றப்ப அந்த hydrogen சுத்தி electron density check பண்றாங்க. So இங்க பாத்தீங்கன்னா அந்த shielding de-shielding zoneல அந்த shielding zoneல என்ன ஆகுது electron density அந்த zoneல அதிகமா இருக்கு and எங்க de-shielding zoneக்கு electrons electron density கம்மியா இருக்கு. So அந்த zone வச்சு தான் அவங்க என்ன பண்றாங்கன்னா they are coming to this conclusion. Okay, so இது மாதிரி these all are explanation to the experimental data. அந்த experimental dataக்கு explanation நம்ம கொடுக்குறோம். நீங்க இதை பத்தி இன்னும் கிளாரிட்டி வேணும்னா ரொம்ப பியூட்டிஃபுல்லா லேம்பர்ட் டிஸ்கஸ் பண்ணிருப்பாங்க அந்த ரிங் கரண்ட் எல்லாமே. நம்மளால ஒரு ஆர்கானிக் கெமிஸ்ட்னால மாலிகுலை பார்த்து ரிங் கரண்ட் சொல்ல முடியாது. சரியா? சோ நம்ம எப்படி அதை பர்சீவ் பண்ணிக்கிறோம், சோ நம்ம எப்படி அண்டர்ஸ்டாண்டிங் உள்ள கொண்டு போய்க்கிறோம். சோ லேம்பர்ட்டோட எக்ஸ்பிளனேஷன் படி இல்லைன்னா அந்த சயின்டிபிக் டேட்டாஸ் படி நம்ம எப்படி என்ன கன்க்ளூஷன் நம்ம அரைவ் பண்ணிக்கிறோம்னா ஒரு காம்பவுண்ட் அரோமேட்டிக்கா இருந்துச்சுன்னா ரிங் கரண்ட் இப்படிதான் இருக்கணும். சோ இப்படி இருக்கிறப்ப செகண்டரி ஃபீல்ட் இப்படிதான் இருக்கணும். அப்படி இருக்கிறப்ப அவுட்டர் ரீஜன்ல அது அலைன் ஆகுது, இன்னர் ரீஜன்ல என்ன ஆகுது, ஆப்போஸ் ஆகுது. So these all are scientific data. நம்ம derivation படிக்கிறோம். Gives Helmholtz law, delta G is equal to delta H minus T delta S. எப்படி நீங்க கேட்கிறீங்க derivation வச்சு வர்றாங்களே. So they have been derived and they have been concluded. So அதே anti-aromatic compound என்ன ஆகுது, zone of electrons என்ன ஆகுது, மாறுது. So அதை பேஸ் பண்ணி they come to this conclusion. சரி, அது பேஸ் பண்ணி தான் அஸ்க்லீன்ல ஏன் அது இப்படி நிக்குது, why it is standing like this, because near the hydrogens you have high electron density. So they presume that since your secondary magnetic field, that is your ring current or the movement, the electron சுத்துது இல்லையா molecule, இது ஒரு pi electron current. So இங்க பாத்தீங்கன்னா you'll be having pi electron current. Pi, that is ring current னு சொல்லுவாங்க. alkyl alkyne ring current alkyne, it will be known as pi electron current. அந்த pi electron சுத்துற current எப்பவுமே p0 ஓட perpendicular-ஆ இருக்கும். So அதனால molecule அப்படி place ஆகுது. So இங்க இப்படி வர்றப்ப என்ன ஆகுது, near the hydrogen it is getting shielded. So these all are scientifically done by a technique, and the technique, to be very frank, எனக்கு ஞாபகம் இல்ல, but I've seen images. அந்த இமேஜஸ்ல பாத்தீங்கன்னா அந்த காமிச்சிருப்பாங்க அந்த zone of electron density ஒரு cloud மாதிரி காமிச்சிருப்பாங்க. அதை பேஸ் பண்ணி தான் they are just coming to this conclusion. Is that okay?
Okay. Yes,
Okay.
yes, yes, thank you.
Okay. So now you can see that இப்படி கேட்டாலும் you should be able to answer. Inner hydrogen should be shielded and outer should be de-shielded. Okay, so the inner protons resonate at my 9.2. No, inner should be shielded. And the 6 protons na inner protons da artham, it means shielded zone. I agree. So option A and C are right answer. So what is the correct option? A and C correct on observation. So what is the right answer? Answer D. Based on that, I can say that option A and C is the right answer. If any problem is given or based on the delta values, chemical shift values, will you be able to solve the problems? Yes? Yes?
Yes, ma'am.
Yeah. So first, so 3 categories you have finished. So you should be thorough with. So next class when I come, I'll be bringing you problems based on the recent question papers. Okay. So I want you to solve it. Okay. So just think that you're sitting in an exam hall. So we will discuss so that you will have an idea that okay, this is the way we should approach the NMR problems. So you will know where you stand. Okay. So நீங்க answer பண்ண முடியலனா உங்க எங்க வீக்கா இருக்கீங்க பாருங்க. You can always ask me doubts, so you can just get thorough with it. Okay. Okay. Next concept is splitting. Okay. So before going to splitting, we should know something as intensity of signals. Okay. Generally mean that, so suppose you have an NMR peak. So NMR peak, the area under the peak will tell you about the number of hydrogens. In IR, I've already told you, you should not count like that. In IR, the area under the peak does not correspond to the concentration. The intensity will peak off depend on what? IR, what does the intensity of peak tell you about? IR. The peak intensity talks about what?
Transmit and absorbance.
Yeah. So if you have intensities that is that is okay. If I have 0% of transmittance, that shows that is a very intense peak. So IR you'll be having percentage transmittance 0, 100. So if the peak comes like this, so a peak which is coming near 0 will be highly intense. So intensity of peak depends upon what? What are the parameters which decides the intensity of peak in IR spectroscopy?
Ma'am, dipole moment, ma'am. Dipole moment,
Very good,
electronegativity.
very good. So dipole moment. So dipole moment will depend upon what? Dipole moment change.
Ma'am, electronegativity.
Yeah, electronegativity. What else? What else? So highly electronegative. If you have very strong electronegative difference, then you'll be having very strong dipole moment difference. Therefore, you'll be having very high dipole. Therefore, you'll be having strong intense signal. What is the second point which we have discussed? Stretching and bending vibrations. Generally, what did we see? What did we say in that? Stretching vibrations will be having more dipole moment compared to a bending vibration. Therefore, stretching vibration will be having more intense signal than bending vibration. Can you recall, guys? Guys, can you recall?
Yes, ma'am.
Yes, yes, okay. So, but in proton NMR, the story is different. What does the story say in proton NMR? The intensity of signal will depend upon the number of protons. So, if you have high intense signal, that shows the number of protons is high. If you have low intensity, that shows the number of proton is low. That is the only thing which you can talk about. Okay. So, intensity of signal will depend upon the number of protons. Okay. Suppose I have 3 sets of protons. Suppose problemல உங்களுக்கு number of protons கொடுக்கல, intensity மட்டும் கொடுத்திருக்காங்கன்னா நமக்கு normally இது உங்களுக்கு கேட் சிஎஸ்ஆர் இது வரைக்கும் அந்த ப்ராப்ளம் பார்க்கல. சப்போஸ் உங்களுக்கு நீங்க ரெகுலர் எம்எஸ்சி படிக்கிறப்போ உங்களுக்கு இந்த மாதிரி ப்ராப்ளம்ஸ் கொடுத்திருக்காங்கன்னா எப்படி அப்ரோச் பண்றது? So now you can see that intensity கொடுத்திருக்காங்க. So 33, 23, 54. First இந்த total integration என்ன பண்ணினோம்? ஆட் பண்ணினோம். மொத்தமா ஆட் பண்ணி 54 plus 23 plus 33 110 units. So நாங்க நார்மலி இப்ப நான் கிளாஸ்ல இருந்தேன்னா நான் ஸ்கேல் கொடுத்து மெஷர் பண்ண சொல்வேன் இன்டென்சிட்டியை. So this all you will do. Okay, so intensity மெஷர் பண்ணி total units ரெடி பண்ணி number of protons 10 கொடுத்திருக்காங்க 10. So 110 divided by 10. So you'll be getting 11. So 1 unit, 11 units will be equal to 1 proton. So 33 will be equal to 3 protons. 23 will be equal to 2 protons. 54 will be equal to 5 protons. That is how we find. So this signal corresponds to 5 hydrogens. This signal corresponds to 2 hydrogen. This signal corresponds to 3 hydrogen. That is a signal at 2.1 delta. It is having 3 hydrogens like that. Suppose they are not giving the number of hydrogens in your signal. So intensity of the peak will tell you about the number of protons. So number of protons தெரியணும்னா என்ன செய்யணும்? நீங்க ஒரு புரோட்டான் ஒரு சிக்னல் கீழே எத்தனை புரோட்டான் தெரியும் என்ன செய்யணும்? அந்த மொத்தமா இன்டென்சிட்டியை இந்த மாதிரி கொடுத்திருப்பாங்க. So this is integration. இப்ப இருக்க NMR என்ன பண்றாங்கன்னா இந்த இன்டெகிரேஷன் கால்குலேட் பண்ணி கீழே நம்பர் ஆஃப் புரோட்டான் சொல்லிடுவாங்க. So integration போட்டு இப்படி போட்டு 4 ஹைட்ரஜன் போட்டு 2 ஹைட்ரஜன் போட்டுருவாங்க. So இந்த மாதிரி நீங்க என்ன மாதிரி ஒர்க் ஷாப் எல்லாம் போனீங்கன்னா உங்களுக்கு அவங்க சொல்லி கொடுப்பாங்க இன்டெகிரேஷன்ல இருந்து புரோட்டான் வர்றதுக்கு. சப்போஸ் இன்டெகிரேஷன் கொடுக்காம அதே உங்களுக்கு டெஸ்டிங்கா வச்சுக்காம என்ன பண்ணணும் நீங்க? ஸோ இன்டெகிரேஷனை பார்த்து சென்டிமீட்டர்ஸ்ல நோட் பண்ணிக்கிட்டு டோட்டல் சென்டிமீட்டர்ஸ் வச்சு நம்பர் ஆஃப் புரோட்டான்ஸ் டிவைட் பண்ணீங்கன்னா this 11 centimeters equal to 1 proton. அப்படி வந்தோம்னா 33 will be equal to 3 protons. That is how we'll find the number of signals. Is that okay? NMRல normally CSR gateல இந்த மாதிரி ப்ராப்ளம்ஸ் நான் இது வரைக்கும் பார்க்கல. அதனால don't worry about this. This is okay, but you should know it. Okay, wow. Is that okay for all of you?
Yes, ma'am.
Yes. Okay, okay. Now comes the spin splitting. Okay, spin splitting. Now you can see, here I have taken CH2, CH. So this H2 are attached to 1 bromine, but this H is attached to 2 bromine. So they are different. So now this will be having a different delta and this will be having different delta. Suppose I say this is A proton, so delta A and delta B, they'll be different. So they'll have different chemical shift. What else will differ in these two? So these A hydrogens have 1 B hydrogen and this B hydrogens has 2 A hydrogen. Now what will the change such arrangements will make in the spectrum of NMR? What will happen? Okay, so that is what is known as spin splitting. Just keep in mind that only the chemically non-equivalent protons will split each other. So in the proton A will split the proton B. So ரெண்டு A proton இருக்கு, ரெண்டு A proton தன்னுக்குள்ள split ஆகாது. There will be no splitting between A protons. A will split B, B will split A. But A will not split each other. So ஒரே weak. So they are A ஓட neighbor B. A ஓட neighbor B. So A ஒரு வீட்டுக்குள்ள இருக்கு, B ஒரு வீட்டுக்குள்ள இருக்கு. So A ஓட neighbor B. So neighboring houses குள்ள தான் splitting நடக்கும். ஒரே house குள்ள இருக்க protons தனக்குள்ள split ஆகாது. So what I mean by saying the protons in same house, the proton in same house means they are chemically equivalent protons. They have same chemical shift. Okay. So protons which have same chemical shift, that is they are chemically equivalent, will not split each other. Okay. So first condition for splitting is that first condition for splitting is that you should be having chemically non-equivalent hydrogens. So chemically non-equivalent hydrogens are splitting pannu. Is this point clear to all of you? Yes? Yes, guys?
Yes, ma'am.
Yeah, okay.
Yes, ma'am.
Now let us check why you have splitting. Okay, so generally we say that if I have this case, I'll be saying that I'll be having two hydrogens, and neighboring I have one hydrogen. So this is hydrogen A and hydrogen B. So the rule is n plus 1 rule. So A hydrogens has one neighbor. So n plus 1, where n is number of neighboring hydrogens. N is number of neighboring hydrogens. So for A hydrogen, you have one neighbor. So 1 plus 1. So A will be doublet. So A protons will come as doublet. Now B has n plus 1 rule follow pandrom. So B ku rendu neighbor. So 2 plus 1, which is equal to 3. So B will be seen as a triplet. Avlodhan. Okay, but why you have this splitting? Why you have this splitting? So just look here. So when you have no adjacent hydrogens, when you have no adjacent hydrogens, with no adjacent hydrogens, the absorbing hydrogen feels only one field. So it will be coming as, so in the ஒரு field மட்டும் தான் feel பண்ணும். The ஒரு field மட்டும் தான் feel பண்ணும். Therefore, it will experience only, so உள்ள வாங்குற field ஒரே மாதிரி இருக்கும், ஒரே மாதிரி split ஆகும். So ஒரே மாதிரி energy தேவைப்படும். Therefore, it will be giving you a signal peak. But if you have an adjacent hydrogen, so உங்க பக்கத்துல ஒரு hydrogen இருக்கு. Suppose I have a hydrogen in my neighborhood. That hydrogen can either oppose. Now I'm talking about the spin of the neighboring hydrogen. This is the neighbor, என்னோட neighbor. neighbor எனக்கு வர வேண்டிய external field ஓட oppose பண்ணலாம், இல்லனா எனக்கு வர வேண்டிய external field ஓட align ஆகலாம். So நான் feel ஆகுற B0 பத்தி பேசிட்டு இருக்கேன். நான் feel ஆகுற B0 எந்த ஒரு கலப்படம் இல்லாம அப்படியே நான் feel பண்றேன். யாருமே influence பண்ணல. I'm feeling only the B0. No influence. Then I'll be having no splitting. I'll be having only one signal. But a neighborல இன்னொரு ஹைட்ரஜன் உட்கார்ந்திருக்காங்க. அந்த ஹைட்ரஜன் either என்ன ஆகலாம், ஆப்போஸ் ஆகலாம், இல்லனா அலைன் ஆகலாம். So அப்படி ஆப்போஸ் பண்ணுச்சுனா நான் எக்ஸ்பீரியன்ஸ் ஃபீல் பண்ற ஃபீல் என்ன ஆகும், டிக்ரீஸ் ஆகும். அதே அலைன் ஆச்சுனா நான் எக்ஸ்பீரியன்ஸ் பண்ற ஃபீல் என்ன ஆகும், இன்க்ரீஸ் ஆகும். சோ நான் எக்ஸ்பீரியன்ஸ் பண்ற ஃபீல் டிக்ரீஸ் ஆகுதுன்னா என்ன அர்த்தம்னா நான் என்ன ஆகுறேன். So normally நம்ம என்ன பார்த்திருக்கோம், ரெண்டு டைப் ஆஃப் ஹைட்ரஜன் which is shielded hydrogen will feel less field, de-shielded will feel less more field. So now I am remaining same. So let me converse here. So I am the A proton, நான் the A proton. சரியா? ஏன் பக்கத்துல ரெண்டு B proton வச்சுக்கோங்க. I have two B protons in neighborhood. So this is the external field which I am feeling. இது external field, எனக்கு இருக்க external field. இப்ப ஏன் பக்கத்துல இருக்கிற B என்ன பண்ணுதுன்னா என்னோட environment influence பண்ணுது. எப்படி influence பண்ணுது, அந்த neighboring B ஒரே ஒரு B proton, suppose I have only one B proton, for example I have only one B proton, and the only one B proton can either align with the external field or it can oppose with the external field. So I am A proton and I have a neighboring which is B proton. That's all. I am A proton, I have a neighboring B proton. And the B proton can either oppose the external magnetic field or can align with the external magnetic field. So நான் experience பண்ற field இது influence பண்ணுது. எப்படினா it is giving me a different notion. எனக்கு different notion கொடுக்குது. ஏனா என்ன சுத்தி இருக்க environment it is influencing. How it is influencing? It is either opposing the external field or aligning with the external field. So HE will experience two different field in the combination. External field or opposite of that, it will be giving me less field. External field align on that, it will give me more field. So B, the influence of B is such a way that A will experience two different fields. One is aligned, the other one is opposed. So I will be split as this is, so the delta scale இப்படி split ஆயிருவேன் நானு. I'll be split into a doublet. So I'll be having less delta, I'll be having more delta. So I was a singlet, Now if I'm split into a doublet, that shows that in the signal key like a delta value, inga delta value so this is having low delta, this is having high delta. So in that enna agudhu, the B proton external field oda enna agudhu, oppose agudhu. In that enna agudhu, B proton external field oda enna agudhu, align agudhu. So I'm experiencing two different environment. One is shielding environment, the other one is de-shielding environment. So that is why I'll be split into a doublet. So suppose I have one A and one B, same will be the experience of B. When B is looking at A can be either aligning or opposing, therefore I'll be having the same experience. Okay, thus splitting for reasons. So இதெல்லாமே நீங்க உங்க சப்ஜெக்ட் படிக்கிறப்ப டீடைலா படிச்சிருப்பீங்க சரியா. சோ நம்ம இத பத்தி உங்களுக்கு doubts you can always ask me. Okay, so when I have one neighboring proton, I'll be split into two because the neighboring proton is giving me two environment. The neighboring proton is either aligning with the external field or opposing the external field, therefore I'll be having two different environment. I'll be having, okay. So suppose I have two protons, two adjacent protons. So here what I say is that since I can have equal number of aligned and equal number of opposing, so the doublet intensity same irukku. I'll be having same intensity because aligned and opposing are of same. Probability of aligning and opposing is same. So 1:1. So the intensity of doublet will be always 1:1. Same intensity level. Ana, suppose I have two hydrogens, that is I am a proton and I'm having two B proton. So A proton, B proton paakrappa, B proton, rendu B proton enna pannalam, oppose pannalam, external field oppose pannalam. Or the two B protons can either align with the external field, rendume சேர்ந்து align பண்ணலாம், இல்லனா ஒன்னு oppose பண்ணலாம், இன்னொன்னு align பண்ணலாம். So now என்ன field experience பண்றேன், I am experience highly de-shielding zone, intermediate between shielding and de-shielding. So எனக்கு மூணு விதமான environment நான் feel பண்றேன். I am experiencing three different fields. So what will happen, this is highly shielding zone, this is de-shielding zone, this is intermediate. Now how many times I'll feel this? I'll feel this one time, I'll feel this one time, and this I'll feel two times. That is why the intensity of triplet is always 1:2:1. 1:2:1. So the rule is n+1. If I have two neighbors, I'll be split as triplet. If I have three neighbors, I'll be split as quartet. So it goes on singlet, no neighbors singlet, two neighbors doublet, one neighbor doublet, two neighbors triplet, three neighbors quartet, four neighbor pentet. So it goes on. Okay, so this is known as n+1 rule. Okay, so if I have only one peak singlet, so here neighboring, number of neighboring protons 0, 1, 2, 3, 4, 5, 6, greater than 6. So if I have no neighbor, I'll be singlet. If I have one neighbor, I'll be doublet. If I have two neighbors, I'll be triplet. If I have three neighbors, I'll be quartet. If four, it's quintet. 5, sextet. 7, septet. Okay, so this is the case. So if I have one A and one B, A will split B as doublet, B will split A as doublet. I have one A and two B, so A will be triplet, B will be doublet. I have two A and two B, so B will be triplet, A will be triplet. I have 2A and 1B, so 3B. So 3B will be, B has two neighbors, so B will be triplet. A has three neighbors, so A will be quartet. Remember, always remember that whenever you have this triplet quartet combination, think about ethyl group. It's a problem solving useful. Here I have one A proton, three B protons. So A has three neighbors, so A will be quartet. And B is having one neighbor, therefore B will be doublet. Okay. So you can see quartet and doublet. Okay. Now these two CH3 are same. So these two CH3 has one neighbor So they'll give you only one doublet. So they are singlets. So chemically equivalent protons will give you one signal. So around 1.7, I have a doublet, and you can see the intensity, very strong intensity, because it comprises of 6 hydrogens. And only one hydrogen's neighbor, it has 6 hydrogens. So 6 plus 1, it will be 7, septet. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. So I'll be having septet because I have neighboring 6. So எல்லாத்தையும் add பண்ணிடணும், ஒரு பக்கம் மட்டும் பண்ணக்கூடாது. So neighboringல 6, 6 plus 1, 7. So septet ஆயிருவேன். Septet ரொம்ப கம்மியான intensity. ஏன் கம்மியான intensity? Because it is only one hydrogen. So very low intensity. Is this point clear, guys, for all of you? Is this point clear?
Yes, ma'am.
Okay. Okay. So before going into splitting, so you might have studied the Pascal's triangle. So Pascal's triangle is very easy to understand. So if you have like something like this, so 1, 1, 3, 1, 1. So if I have no neighbors, N0, I'll be split as singlet. The intensity of signal is 100%. If I have one neighbor, I'll be split into doublet. The intensity of doublet is 1:1. And this is triplet. If I have 2 neighbors, I'll be split into triplet. 1:2:1. If I have 3 neighbors, I'll be split into quartet. 1:3:3:1. Okay. So just one cross check. Okay. So one cross check. So suppose I have 3 neighbors, 3 hydrogen neighbors. So 3 protons will be aligning. So all the 3. One second. So if I have 3 neighbors, all the 3 can oppose, all the 3 can align, or 2 can align, 1 can align, 2 can oppose. So I can have 3 probability for this. Or 2 can align, 1 can oppose. So what is the intensity of a quartet? So I have 3 hydrogens, neighbor 3 hydrogens. I'll be split as n+1. So I'll be a quartet. Now what is the intensity of quartet? 1:2, 3:2, 3:1. So likewise I cannot do it for all the protons. So that is why we go to the Pascal's triangle. Very easy to solve. Okay, the panena intensity of quartets kandupidichala, intensity of, suppose adhe 4 neighbors na I'll be split into a pentate. So the intensity enna irukku ketanga takku illa potu paathalam. So intensity of pentate will be 1:4:6:4:1. What is the intensity of sextate? 1:5:10:10:5:1. So likewise, you can find the intensity of any multiplicity. This problem this is also asked in a problem. Okay.
Ma'am,
Yeah?
I have a doubt.
Yeah.
Ma'am, we know that the splitting of peaks depends upon neighboring protons. அப்படிதானே ma'am?
Yeah, yes.
Ma'am, then but the intensity of the signal depends upon neighboring proton or its own proton, ma'am.
No, miss. Intensity na என்னோட intensity. நான் split ஆறது because of neighbor. ஆனா என்னோட intensity is because of my type of my protons. So நீங்க பாத்தீங்கன்னா A protons are 6 A protons. அதான் intensity அதிகமா இருக்கு. Here B is only 1 B proton. Therefore intensity கம்மியா இருக்கு. Only 1 B proton. Splitting is due to neighboring proton and my intensity is me. நானு என்னோட intensity will be because of me. Splitting is because of the neighboring. So I am doublet. A is doublet because of 1 B proton. A is doublet because of 1 B proton. But I am having a very high intensity because I have 6 identical protons. TMS. TMS highly intense signal. Why highly intense? Because I have 12 hydrogens highly chemically equivalent. That's ரொம்ப intensity. A small amount of TMS podum. Is that clear?
Ma'am, and then the intensity of the peak depends upon the neighboring protons. அப்படிதானே ma'am?
No. Intensity.
Ma'am, இந்த Pascal triangle நீங்க சொன்னீங்களா ma'am? 1:2:1. அந்த
இந்த splitting ஓட intensity. So நான்
yes
ஒரு
ma'am, yes
doublet.
ma'am.
So நான் ஒரு doublet எடுத்துக்கிறேன்னா, அது suppose அதோட intensity எப்பவும் பாத்தீங்கன்னா, for example, so I got your point. நீங்க அந்த intensity சொல்றீங்கன்னா, if 1:5:10:10:5:1, that is the suppose ஒரு proton ரொம்ப குட்டியா இருக்கும். அந்த பென் அந்த ஹெப்டேட் ரொம்ப குட்டியா இருக்கும். இவ்வளவு பெருசா இருக்கு. அப்ப தெரியுதா ரொம்ப குட்டியா இருக்கும். So suppose I have a doublet ரொம்ப பெருசா இருக்கு. So இது 1:1 அந்த intensity சேமா இருக்கணும். Suppose this doublet is given by only one hydrogen, ரொம்ப குட்டியா இருக்கும். doublet தான் இருக்கும். doublet எப்பவுமே எப்படி இருக்கணும்? 1:1 இருக்கணும். ஆனா intensity எப்படி இருக்கு? கம்மியா இருக்கு. So intensity of the multiplex நம்ம இது 1:5 எதை பேசுறோம்னா எப்படி டிஸ்ட்ரிபியூட் ஆகுது? doublet எப்படி டிஸ்ட்ரிபியூட் ஆகும்? doublet நம்ம இப்படி வரையக்கூடாது. doublet நம்ம இப்படி வரையக்கூடாது. சரியா? சிங்லெட் இப்படி இருக்கு. டப்லெட் நான் எப்படி வரையக்கூடாது? இப்படி வரையக்கூடாது. ட்ரிப்லெட் நான் எப்படி வரையக்கூடாது? இப்படி வரையக்கூடாது. ட்ரிப்லெட் ஒரே மாதிரி வரையக்கூடாது. ட்ரிப்லெட் எப்படி வரையணும்? 1:2:1. சோ ட்ரிப்லெட்டோட ஷேப் ஆஃப் மல்டிப்ளெட் பேசுறது யாரு? மல்டிப்ளெட்டோட ஷேப் பத்தி பேசுறது யாரு?
Neighboring protons ma'am.
No. மல்டிப்ளெட் ஷேப் பத்தி பேசுறது ஷேப் ஆஃப் மல்டிப்ளெட். நான் ட்ரிப்லெட் தான், நான் குவார்டெட் தான், அதை அக்ரி பண்ணிக்கிறேன். ஸ்பிளிட்டிங் என்ன ஸ்பிளிட் பண்றது neighboring protons. ஆனா என் மல்டிப்ளெட் ஷேப் that is triplet இப்படி இருக்க கூடாது. ட்ரிப்லெட் இப்படிதான் இருக்கணும்னு பேசுறது யாரு? Pascal's triangle like intensity or number of neighboring protons. So you know understanding. So in the intensity has nothing to do with the neighboring protons. Neighboring protons nala varudhu, but nothing to do with my number of protons. Na 10 proton இருந்தாலுமே என் triplet எப்படி இருக்கணும்? 1:2:1. So triplet, suppose I have very high number of protons. So triplet என்ன ஆகும்? பெருசா வரும். நம்ம protons கம்மியா இருந்தா என்ன ஆகும்? triplet சின்னதா வரும். அவ்வளவுதான். So triplet ஓட intensity, that is what is Pascal's triangle talking about. Pascal பேசுறது tripletல எப்பவுமே 1:2:1 இருக்கணும். அதான். இது புரிஞ்சா உங்களுக்கு? Do you understand this?
Yes ma'am.
அதுக்கும்
Okay.
சிக்னல் இன்டென்சிட்டிக்கு வித்தியாசம் இருக்கு. சரியா? டப்லெட்ல 1:1 இருக்கணும். டப்லெட் பெருசா இருக்குதா சின்னதா இருக்குதா டிபெண்ட்ஸ் upon what? டப்லெட் பெருசா இருக்கா சின்னதா இருக்கா depends upon what?
Its own proton.
Intensity means depends upon its own. நான் எத்தனை protons இருக்கு? 6 proton doublet அல்ல 1 proton doublet, அத டிபெண்ட் பண்ணதா அந்த signal intensity. Okay, now coming to the coupling constant. So splitting பாத்துட்டோம், coupling பாத்துட்டோம். After class we'll be having the final set of problems. Okay, so coupling constant வச்சு சில problemsல details வரும். நான் ரொம்ப டீடைலா போறது இல்ல. So suppose I talk about Kaplan's equation. The Kaplan's equation talks about the vicinal coupling. So you have carbon with 2 methylene protons. They are known as geminal protons. Geminal, that is hydrogen attached to the same carbon. Geminal. So this is known as 2 bond coupling, 2J coupling. So coupling constant is given by the alphabet J. J is known as coupling constant. J is known as coupling constant, and the unit of coupling constant is hertz. So coupling constant is measured in hertz. Okay, so when I talk about geminal coupling constant, it is known as 2J coupling. Why 2J coupling? Because the hydrogen is separated by 2 bonds. So when we talked about pioneering system, we know that they are diastereotopic. So diastereotopic condition varappa, even the geminal protons, ஒரே கார்பன்ல இருக்க 2 ஹைட்ரஜன்ஸ் என்ன ஆகலாம்? They can become chemically non-equivalent. Diastereotopicல மெத்திலின் ஜெனரலா நம்ம என்ன செய்வோம்? ஒரு CH2 நம்ம chemically non-equivalent சொல்லவே மாட்டோம். பட் ஜெமினலா இருக்கிறப்ப chemically non-equivalent எப்ப வரும்? When the hydrogens are becoming diastereotopic. So coupling, splitting will be only between non-equivalent protons. Nalla manasla ஏத்திக்கோங்க. Coupling will be between only non-equivalent protons. So coupling constant is between non-equivalent protons. Coupling non-equivalent protons நடுவுல மட்டும் தான் நடக்கும். சரியா? இது 2J coupling. ஏன் 2J coupling? Because இந்த 2 ஹைட்ரஜன் கப்பல் ஆக போகுது. இந்த 2 ஹைட்ரஜன் கப்பல் ஆக போகுதுன்னா இந்த 2 ஹைட்ரஜன் நடுவுல இருக்க bonds எவ்வளோ? one bond, two bond. So it's 2J coupling. Suppose I have adjacent carbons, hydrogens. So these type of hydrogens, they are known as 3J coupling because the number of bonds between them is 3 bonds. 3 bond coupling, 1 bond, 2 bond, 3 bond. They have 3 bond away. 3 bond coupling. They are known as vicinal coupling. Vicinal coupling. If you have more than 3 bonds, that is known as 4J, 5J. So greater than 3 nale enna solvona long range coupling. Long range coupling. So you have geminal coupling, 2J coupling, vicinal coupling, 3J coupling, 4J, 5J, 6J, 7J, they are known as long range coupling. Okay. So now coupling irukkunnaale nalla niyavachukonga. Coupling should be between chemically non-equivalent hydrogens. Keep that in mind. Coupling should be between chemically non-equivalent hydrogens. That you just keep in your mind. இப்ப geminal and long range ரொம்ப நம்ம படிக்க மாட்டோம் because problemல ரொம்ப தூரம் வராது. Vicinal is very important. So vicinal coupling constant is given by Kaplan's equation. So a carbon with one hydrogen, a carbon with another hydrogen. Suppose you think of a notebook. This is an open notebook. In the notebookல ஒரு பக்கம் ஒரு பேப்பர்ல ஒரு கார்பன் ஹைட்ரஜன், இன்னொரு பேப்பர்ல இன்னொரு கார்பன் ஹைட்ரஜன். Notebook and a close point. I'm closing the notebook. So we'll be having dihedral angle equal to 0. Notebook and a perpendicular vachirken. Then it will be having 90 degrees. Notebook a complete a flat open panni vachirken. Book a flat open panni vachirken. Then the angle becomes 180 degrees. In the point purida. So notebook la oru pakkam, one plane, the other plane, and the rendu plane naduvula irukra angle the dihedral angle. So Karplus enna kandupidikirarna, he is plotting the coupling constant against the dihedral angle. Dihedral angle is from 0 to 180. So 0 to 180. What he finds is that when the dihedral angle is 180 degrees, in the mari 180 degrees, you have very high coupling constant. High coupling constant. And when the dihedral angle is 90 degrees, so moon range 0 to 30, 60 to 90, 160 to 180. So 0 to 30, low dihedral angle, you will be having high J value. When you have dihedral 69, you will be having low J value. But when you have the dihedral angle nearly 180, will be having the highest J value. So this is based on Kaplan's equation. Is this point clear? The point clear? Point clear?
Ma'am, 0 to 30 and 60 to 90 same adana ma'am irukku intensity.
Inga 0 to 30 inge irukku. 60 to 90.
Okay ma'am.
Lower irukku parunga value. Coupling constant value lower irukku.
Okay,
coupling constant
okay,
value
ma'am,
adhigama
okay.
irukku. So 0 to 30 values adhigama irukku. So in the range values are higher. 60 to 90 values 0 ah irukku. Again 180 என்ன ஆகுது, value பயங்கரமா shoot up ஆகுது. Okay, so J value when you have 0 degrees, you'll be having around 8 to 10. J value when it is around 90 degrees, it will be around 0. Coupling constant will be 0. Or 0 to 1 vachikalam andha mari range la irukum. When J is 180 degrees, the coupling constant values will be around 10 to 14. So nama idella solo J 1 anti-periplanar. When the hydrogens are anti-periplanar, you'll be having the highest coupling constant value. And this is known as syn-periplanar. Syn-periplanar, when the hydrogens are on the same plane, syn-periplanar, they'll be having the next highest value. But when the hydrogens are orthogonal 90 degrees, they'll be having the lowest value. இதான் காப்ளஸ் கண்டுபிடிச்சது. நான் ரொம்ப டீடைலா போக மாட்டேன், ஏன்னா அதுல டீடைலா போனேன்னா then I'll not have classes to complete the NMR. So நீங்க தியரி நீங்க கண்டிப்பா இதை படிச்சிருப்பீங்க. So when you study theory, you'll be studying these all things in very detail. Okay. So coupling constant according to, so I have he has solved the binomial expressions. So based on the solution of the binomial expressions, what he finds is that when the coupling constant is highest for the dihedral angle of 180, when you have very low dihedral angle, the coupling constant is the next highest, and when the coupling constant is 190 degrees orthogonal, then you have the lowest coupling constant values. Is this point clear? Dihedral angle and J value clear aayega? Guys, dihedral angle J value clear aayega? Dihedral angle 0, 180, 90. So 0 la adhigama irukum, 90 la korayum, 180 la koodum. In the diagram clear aayega? Ka plus equation diagram.
Yes.
Dihedral angle and connection between coupling constant is clear or not? Yes?
Yes, ma'am.
Yes? See, all of you, is it clear?
Yes, ma'am. Okay, ma'am.
Okay, okay. So what they say is that when you have, so this is J value strongly depends on the dihedral angle between the CH bonds, which determines the extent of orbital interaction. So what they are saying is that when you have syn periplanar and anti-periplanar, you have better interaction between the orbitals. That gives you the high J value. But when they are 90 degrees, so there is no interaction. So you can see the orbitals have no interaction. That is why you have very low coupling constant values. Okay, so the syn also gives some steric repulsion. That is why the coupling constant value is decreasing. Whereas in anti, you don't have such steric interaction. Therefore, it gives high value. 1 second, guys. 1 second. Okay, so these are the orbital interaction pictures, which clearly explains why the anti-periplanar syn periplanar gives you high value for the coupling constant. So 180 in a trans, something like this. Hydrogens trans to each other, hydrogen cis to each other. Condition, they should be chemically non-equivalent hydrogens. So these are trans, they'll be having high coupling constant, J value adhigama irukum. They are cis, they'll be having low J value. J value will be less compared to this. And when you have 90 degrees, they'll be the still lowest. And comparing the geminal, vicinal, and long range, generally the J vicinal, 3J is greater than 2J, which is greater than long range, but it depends upon long range, that is greater than 4. This depends upon the molecules. Sometimes some geminal coupling constants are very high. That is not very important. நீங்க தியரிட்டிக்கலா நீங்க காலேஜ் படிச்சுக்கோங்க. ப்ராப்ளம் சால்விங்ல ரொம்ப தேவைப்படாது நமக்கு. Geminal and long range. Now you can see here the cis. See, for if you have electron donating group, generally electron donating group will increase the coupling constant value. Electron withdrawing group will decrease the coupling constant values. Because coupling is because of the electrons, okay? So electron or information, electron density nala coupling nadakudhu. So now romba detail inga poga virumla because that will take lot of time, okay? So electron withdrawing group industry coupling constant value korayum, electron releasing industry coupling constant value increase agum. So silicon 8, you have compared to this, you can see you have electron withdrawing, you'll be having low value. So when I have a lithium here, the cis coupling, cis, that is these two, this is having a value of 19.8, whereas this trans coupling has a value of 23.9. Same here, okay? And when you have electron withdrawing group, the cis coupling has a value of 4.7, and the trans coupling has a value of 12.8. But in general, the J180 is greater than J0 always, okay? So geminal is lesser than cis, which is lesser than trans. So generally trans is having highest, then you have the cis, and then you have the geminal. Okay. So based on this, guys, we'll be solving the problem in the next class. So one last thing which I want to discuss here, suppose you take chloropropionic acid. You can see they are cis, and here they are trans. So here the coupling constant value is 14 hertz. Here the coupling constant value is 8 hertz. So based on the coupling constant value, you can say whether it's a cis, whether it's a Z isomer or a E isomer. So based on the coupling constant values, I can tell you, suppose I give you a molecule like this, CH double bond CH, Cl, COH. And I say that the coupling constant value is 14 hertz. So base meaning என்ன சொல்வீங்க இந்த இந்த ஸ்ட்ரக்சர் என்ன சொல்வீங்க trans structure சொல்வீங்க ஏன் நமக்கு ஏற்கனவே தெரியும் டிரான்ஸா இருந்துச்சுன்னா கப்ளிங் கான்ஸ்டன்ட் வேல்யூ அதிகமா இருக்கும் ஏன்னா டிரான்ஸ்ல diagonal angle 180 degrees ஆ இருக்கு it will be having high coupling constant values. Do you agree guys? Yes or no?
Yes, ma'am.
Okay. So just revise this and come when you come for the next class so that we can solve problems on this. Okay. This becomes the last part of the discussion. Okay. All theoretical discussions are over. So next class onwards, you'll be having completely problems alone. Only problems. So the next set of problems will be based on splitting pattern. Splitting pattern and coupling constant, which was 6 to 7 questions. Then after that, you'll be having the complete 4 marks questions. CSL 4 marks question gate higher order questions that will be there. So that will be based on coupling constant, IR and NMR values and splitting patterns. So please go through the previous class portions when you come for the next class. Is that clear, guys?
Yes, ma'am.
So maybe next session, next to next session, we'll be finishing NMR and then we can go to the mass. Okay. Thank you so much, guys.